Hello Algebra 2. This video lesson is going to show how to solve exponential and logarithmic equations, as the title indicates, and it is, as this says, based on chapter 8.6 in your textbook. You'll remember the last video lesson that I gave you was from chapter 8.4, and it focused on how to make use of inverse properties. And we had both of these examples in that video lesson. We talked about the fact that when bases match here with a log, your result is simply going to be this exponent here, 4. And similarly, when bases match with an exponent, your result is simply going to be the thing that you were taking the log of, that 3, and that's the answer that you get on the right here. So we are going to, and then in class I promised you that we would make use of these inverse properties in solving exponents and logs, and we are going to do that today. But the first couple of examples that I'm going to give you are even easier, and it's not necessary. So it's going to take me a couple of slides to get to the point of making use of those inverse property rules. Let's talk about an easier example. And by the way, as this slide shows, two different situations. I'm going to show you how to find what x is when it's in an exponent, and then separately I'm going to show you how to find what x is when it's in a log. The easiest situation on the left here is when the bases match. We'll talk about that in a second, what to do when that happens. And then the next easiest, the bases don't match, but I'll talk to you about what to do when they don't match. And then lastly, this third example, well, here is where pulling in the properties of inverses is going to help a lot. On the right side, finding x in a log. The easiest situation is when the bases of the logs match. But in the second situation, there is no log on the right side, and this is going to be another case where I'm going to show you, and just be patient for a second, but I'm going to show you how to make use of the inverse properties we learned from chapter 8.4. So let's get started with that first example here, the easiest situation. I'm just going to go right to it. If the bases match, then x has to be the same thing as 4x plus 5, right? You're really saying that 2 to something is equal to 2 to something, so that somethings are what match. If x is equal to 4x plus 5, then this is simple algebra, and you should be able to see. Hit the pause button if you need to, but you should be able to see why x is negative 5/3. This is an example that the textbook doesn't even bother to walk through. Instead, their first example is what I call the second situation here. And here is example 1. On the left, we've got a power. On the right, we've got a power. But the bases don't match. When that happens, I recommend you look to see whether or not you can get them to match. If you easily can, then you don't need to use the properties of inverses from chapter 8.4. Instead, you can simply say, well, wait a minute, 4 is 2 squared, 8 is 2 cubed. Now I've got matching bases. So now all I have to do, as the textbook says, is distribute that multiply the 3x times the 2, and here multiply the 3 times the x plus 1. Now I've got matching bases, and that means, like on the previous example, 6x must be the same thing as 3x plus 3, and then it's a simple algebra 1 problem to solve and to find that x is equal to 1. I do have to give you one caveat. Go back and double check, because these are situations where you get extraneous solutions, like in the previous chapter, chapter 7. So you're going to have to make sure that your left result really does match your right result. Here it does. If you plug 1 into the left side and into the right side, you do get matching results. So there's a similar question. Hit the pause button and you come back. I'm going to show you the answer, but I want you to work this one through. Okay, I'm going to assume that you did that. And there is the answer worked all the way through. This pen that I'm working with is a little difficult to write with, so I didn't simplify it further, but it really simplifies down to negative 1 over 5. And that's what you should have found for x, that x is equal to negative 1 over 5, or x is equal to negative 0.2, whichever way you wrote it. Hit the pause button if you need to see all those steps worked through. I'm going to move on. Okay, the third and hardest example that the textbook walks through is best solved making use, as I promised, making use of the lessons from chapter 8.4, the inverse properties. Let's look at it this way. As the textbook says, when it's not convenient to make both sides match. What you ought to do is turn 2 to the x into log base 2 of 2 to the x. Really what you're doing is turning the left side into a log with matching bases. Well, if you're going to turn the left side into a log, you've got to treat the right side the same way. So the right side similarly becomes log base 2 of 7. The textbook just says take log base 2 of both sides. All right. Well, on the left side, making use of that rule that I talked about in my previous video lesson, the left side is simply going to be x. So now x is equal to the log base 2 of 7, and I've taught you in class how to use your calculator to figure out what that is. It's the log of 7 divided by the log of 2, which becomes roughly 2.8. And that's your answer, though you can always double check, and probably should, to make sure it's true. Third example, very similar to the previous one, slightly more complicated. I want you to hit the pause button and see if you can work this one out. Okay, well, admittedly, this example is right out of the textbook, so you could have simply looked at the textbook steps. I'm just going to walk you through those. The first thing they do is they move the 4 over. And now they've got to take logs of both sides because there's no easy way to make 10 match 17. So take log 10 of the left side. If you're going to do that, take the log base 10 of the right side. Again, notice they didn't bother saying that it was base 10. We don't need to when it's base 10. Now, if this is log base 10 of 10, then those will cancel, and I'm simply going to have 2x minus 3 on the left. On the right, I still have the log of 17. And then this is now a fairly straightforward problem to solve. I move the 3 over, I divide everything by 2, and ultimately I'm going to need to figure out what the log of 17 is. You're going to find that it turns out to be about 2.115. Hit the pause button and look at this, or again, study your textbook if you need to. Come in with questions if you have them about this. I'd be happy to go through this problem and similar ones. Your task, though, if you did get that, is to prove that to me. Here's a problem taken straight from the back of the textbook. Question 42 in chapter 8.6. Go ahead and figure out what x is in this situation. In fact, I'm showing you that x turns out to be about 2.4. What I want you to show me is the steps you took in between to find 2.4. That will show me that you understood this process and did go through all the steps that I've taught in this video lesson. Hit the pause button if you need to copy the question down, but I'm going to move on to the next slide. Okay, now we're on the right side. On the left, we talked about how to find x when it's in an exponent. Now let's talk about how to figure out what x is when it's in a log. The easiest situation is the first one. In the second situation, once again, we're going to make use of those inverse properties we learned a couple of chapters ago. Okay. For those easy situations, if the log base matches, if the log base matches on both sides, well then it has to be the case that x is the same thing as y. I do have to give you one warning though. B cannot be 1. Because remember, 1 to any power is always 1. So if this were 1, then you could have been talking about 1 to the first power in one case, and 1 to the 217th power in the second case. So that's that one weird situation. Watch out for that. But otherwise, this general rule applies. Let's look at an example. I'm not going to work this out for you. I'm going to ask you to do that. Notice that they are both log base 3. See if you can figure out, and of course you can look at the textbook if you need to, but see if you can figure out how to solve for x. Hit the pause button. When you're ready, I'm going to walk you through the result. Okay, I'm going to assume that you have worked it out yourself. The first step, since both sides are log base 3, is to get rid of the logs. And really we're saying that 5x minus 1 has to be the same thing as x plus 7. If that's true, then this is an Algebra 1 problem, and x turns out to be 2. Once again, I would recommend that you plug 2 back into both sides just to double check. The textbook did that in this case and found that they do both give you the same result, left and right side. So that is true. This is not a case of an extraneous solution. Let's move on to the harder example though. In this case, we don't have matching log bases on both sides. In fact, the right side is not even a log. So let's make use once again of those inverse properties. The textbook uses a term that you're rarely going to hear me say, and probably rarely going to see, exponentiate. That means turn your problem into a power with an exponent. Make, in other words, what you've got the exponent. And notice what they're saying here. If x is the same as y, then no matter what base you pick, b, for example, to that x has to be the same as b to the y. Well, that stands to reason. There are a couple of warnings I have to make. B has to be bigger than 0. Can't use a negative number. And b can't be 1 once again. Watch out for situations where b is 1, but as long as we're not talking about negatives and we're not talking about 1, this rule works. Okay, so this one I will walk you through. The log base 5 of 3x plus 1 is equal to 2. Now remember what we said. If I raise the left side so that that's my exponent with base 5, then I'm going to have bases that match. And 3x plus 1 is going to drop down. But in order to do that on the left, I had to make base 5 on the right. So it's 5 to the second power. Okay, so now the left side is simply going to become 3x plus 1. The right side stays 5 squared. Let's just call that 25. And now that's a simple Algebra 1 problem to solve. And it turns out that x is 8. Double check your work by plugging it in to make sure you didn't get an extraneous solution. It does check once again. So that's the right answer. X is 8. There's one for you to try. It's a little bit harder. Hit the pause button when you come back. I'm going to show you the worked out solution. Okay, I'm going to assume that you did that. You would have moved the 15 over first, then you would have divided by 2, finding that log base 2 of x is equal to 8. You would have made this an exponent with base 2, and that would mean you'd have to make the right side an exponent with base 2. And 2 to the 8th power turns out to be either, well, you can call it 2 to the 8th if you want, or 256. Either way is fine with me. Both of those are good answers. Okay, that's it for the video lesson. This is the final problem that I want you to do to show me that you understood the material. It's another one like question A that I want you to work out and bring me the answer to. Again, it's straight out of your textbook, in this case question 60. This is the problem with x right here, and I want you to show me how to figure out that x turns out to be 0.01, or in other words 1 over 100 times e to the 12th. Bring that in with you, and if you have any questions, bring those too, and I'll be happy to see you next class.